This is an important lesson for a number of reasons. First of all, it is an easy beginner misunderstanding to not realize that numbers on the keyboard are not treated as actual numbers by the computer. For example, if you push the number 4 on your keyboard when you're writing a program, or if a program is waiting for you to type something and you type in the number 4 on your keyboard, that is not treated as an actual value, a quantity of 4. Rather, it is encoded as text. And a number that has been encoded as text is not at all the same thing as an actual number. So it turns out that just as capital and lowercase letters are encoded in a special binary format, the same is also true for numbers. So first of all, let me show you the table and the rules for this process. So here is a table of all of the different way that numbers, as they're typed on the keyboard, are encoded as ASCII text. Now look at the first example here, which is right here. This is 0 on your keyboard, the way it's actually encoded. Notice that it is not the same thing as the value 0. Or take a look at this example. This right here, if you push 3 on your keyboard, it actually gets encoded like this, which is certainly not the value 3. It's actually 33 in hexadecimal. So you cannot just simply add together values for numbers that are typed on the keyboard, because they are not treated as actual numbers. So if you take a look at this table, you should be able to see the structure of number characters. Every number character starts with 0011. And then immediately after that, the actual value of the number is represented by the next 4 bits. So for example, the number 6 starts with 0011, and then the next 4 bits encode the actual binary value for 6. So if you remember, in the context of capital and lowercase letters, capital letters always began with 010, lowercase letters always began with 011, and numbers always begin with 0011. Now that's really all the ASCII you will ever have to remember, because as long as you know that set of rules, you'll be able to form any letter, capital or lowercase, and any number. The most important thing to understand in this lesson by far is to remember that a number typed on the keyboard is encoded differently than the actual value of that number. And this goes for all numeric characters. However, as you can see from the above table, translating a character from ASCII to a real number is not very hard. For example, if we have this value and we want to convert it to the actual value of 3, all we have to do is just set these two ones to a 0. So in other words, if you have a single character that is a number and you want to convert it to an actual number, all you have to do is take these two binary digits and set them to 0, and you will have achieved that goal. So for example, if we have the character 8, as it would be typed on your keyboard, and we want to convert that to the value 8, all we have to do is set these two binary digits to a 0. Now remember that this lesson applies to ASCII specifically. As I stated in the last lesson, ASCII is one of many ways to encode characters, and you should not assume that this is universally true. The purpose of this lesson is to show you that even numbers have to be encoded as characters, and ASCII is one way that this is done. We will explore this in greater detail later.